Okay, here we have Freddie C again with his candy. Alright, so we got Freddie C has $28 and he wants to buy some fancy Halloween candy that costs $4.80. So, like with the other problem, I think most kids think of this problem in terms of multiplication because it's more straightforward. So people think, okay, well, 4.8 or 4.80 or $4.80 times some number equals $28 or close to $28. We want to figure out how many he can buy, so it might not equal exactly $28. And so if you think of it in terms of simpler numbers, so if you think of this as like maybe 28, you can really think of as like, I don't know, 4, and 480 you can think of as 1. And if you think of it as Freddie has $4 and he wants to buy some candy that costs $1 each, well, that's easy. That's 4. That's 1 times something equals 4, and that's also 4 divided by 1 equals something. So really, you wouldn't even think to write down the equation if it was just $4, $1 each per candy. You would just go, oh, well, $1 each per candy, that's 4 candies. But really, that's 1 times 4, or 4 divided by 1, because you have $4 and you're spending $1 per candy, so that's 4 divided by 1, and then it equals 4. With this one though, your 28 is your 4 and your 480 is your 1, so you're basically right here, 480 times something equals 28. Now you can turn that into a problem that you can solve. I mean, you can solve this, but you might be adding 480 plus 480 plus 480 until you get to close to 28, and you're still not going to get your exact answer if you do it that way. I mean, technically you can figure it out that way because of the problem, because how many candies he can buy, but I want you to figure it out using division and figuring out the exact amount. So 4 divided by 1 would be basically, that'd be this 28 divided by 4.8, because remember 4.8 was the 1, or 4.80 is some number. So now we have, this is our problem right here, and we have 28 divided by 4.80, and we always put the first number in the house. So 28 divided by 4.80. So now with this problem, you have a decimal in the divisor, in the number that's being divided into the other number. And you don't have to move the decimal, but practice, people move the decimal so that they can just deal with dividing a whole number into a number. So we move the decimal to the end in order to make it a whole number. And if you move the number here, you have to move it here too, because otherwise you're changing the number, you're changing the problem completely. Now you have candies that cost 480 cents and still $28. So since this number doesn't have a decimal, well, this is $28. You know that $28 can be written like that. $28 can also be written like this. $28 can also be written just like that. Basically, when you don't have a decimal on a number, it always goes at the end of the number. And if you think of it in terms of money, it can make it easier if you've seen money written out like this at the store or in other places where you've seen money written out, I don't know, at school probably. So you know the decimal, since it moved twice here, will always move the same amount. Now, it doesn't matter where the decimal is here, it's always going to move the same number of spaces as it did here, and that's always going to be to the end of that number. So that's 1, 2 more, I'm going to bring it straight up to go right there, and then these become zeros. And since I always tell you, I haven't told you that many times, we haven't been doing division that long, but I will always tell you to go 3 digits past the decimal so that you could round to the nearest hundredth. So I'm going to just add 3 zeros, because then my answer is going to end up having 3 digits past the decimal. So I'm going to do the sevens method again, where I make it really long. And now I'm going to estimate. So I'm going to pretty much ignore the decimal the whole time, except for right now and at the end. So my estimate, I'm going to estimate with these numbers away. So now basically I have 480 into 2800. So 480 is really close to 500, and I know how I can count by 500s, and 2800 is really close to 3000, so I'm going to count by 500s and see how many times I get up to 3000. So 500, 1000, 1500, 2000, 2500, 3000. So that's 6. So my estimate is going to be somewhere between 5 and 6. So I'm going to say that it's approximately 6. All right. Now I'm going to divide. Okay, so if I think it's going to be about 6, well, maybe I can multiply by 5. Maybe if I multiply, because it's going to be between 5 and 6. It's not going to be more than 6, and it's not going to be less than 5. So maybe I multiply 480 times 5. 5 times 8, it's 40, carry the 4. 5 times 4 is 20 plus 4. Ooh, okay. So I'm going to put the 2400 right here. And I can, because it's smaller than 2800. But I can also say, since I have all these other zeros, instead of, if I just subtract this, then I'm going to get all these other zeros. I can say that I multiply it by 5,000. Because I would just add the zeros. It's the same thing if you multiply, it's like multiplying 2 times 1, you get 2, but if you multiply 2 times 10, you get 20. It's always 10 times more. So if you're multiplying by 1,000 or 5,000, it's always going to be 1,000 times more. So add those zeros. Now we subtract. 0, 0, 0, 0, 0, 8 minus 4, 2 minus 2 is 0. I'm not going to put a 0 there because I don't need to. 0 in front of a number, if there's no decimal coming up anywhere. Anyway, I don't need to put the 0. It's not going to make a difference. It's just going to make more numbers for me for no reason. Well, I'm going to maybe try multiplying it by 5 again, since I already have the number. But it's not going to be 5,000 this time, it's going to be 500. So 2400 was times 5. So I can just use 480 times 5 as my base. And then, so 500, if I want to add those 2 zeros. I'm just going to, oh, yeah, now I have 1600. I don't want to multiply by 5 this time, because then I'll have to start back here. So maybe if I multiply it by 3, it'd be better. Try multiplying it by 3. Three times 4, 12. Well, 3 times 8 is 24. Carry the 2. 12, 4. Okay. Oh, that's better. Because then I could start it over here. If I had 2400, I couldn't start it at the very end of the number, which means I would end up with more left over. And I'm just basically trying to figure out what's left over. I'm estimating all of this. and just going step by step. So these are not the only numbers that you could use. You really could just estimate your own numbers. So the sevens method will look different based on who's doing it. So this is going to be 300. And ooh, got 1600 again. Oh, that's kind of nice. I can just use 3 again. Use 3. 3 times 480 was 1440, so I'm going to say 30. And I'm going to end up with 1600. Ooh, I'm almost done. Now I just do 3, because 3, and then I'm going to end up with, all right, so now I have 160 left, and 160 is smaller than my divisor, once I move the decimal, of course. So now I can stop. I know that when my divisor is, when my leftover, it's not going to fit in any more times. So I can stop and I can add all of these up. So I'm going to add them up. I'm going to use purple. I could add them up in my head, but if you are going to add them up in writing, because you're not so sure about adding them up in your head, please make sure to line up your place value. So you have your ones, your tens, your hundreds, and your thousands. Okay, so now I have 5,833. Well, if I look at the problem, he has $28 and he wants to buy candy, and each one costs $4.80. He's not going to buy 5,000 candies. Plus, our estimate was 6. So I think my answer is 5.833. Now, if you're not sure about the estimate and where the decimal goes based on your estimate, then you can say, well, you know the decimal is going to go there because we put it there based on lining it up just straight up. You can say, okay, well, I don't know. The estimate thing confuses me. I hate it. Blah. You could say, all right, well, the rule is we decided how far our numbers were going to go. We added as many zeros as we wanted to, and that was 3 because that's what Miss Crystal wants us to do. So, because Miss Crystal wants us to round to the nearest hundredth. Sorry, losing my mind. All right, so 3 is the last digit, so it's going to go above the last digit. That's the rule. We went this far, that's how far the digits are going to go. So the last digit here goes with the last digit here. And then you just move this way. 3, 8, 5. So if the estimating doesn't make sense, that's the rule that you can remember. Now, our question is, how many can he buy? Well, 5.8, you can't really buy 5.8 candies. So he can buy 5. So really, you're rounding this one to the nearest whole number because of the nature of the problem. He can buy 5 candies. He might be able to get a little bit more money and buy 6, but right now he can buy 5. And is there money left over? Yeah, there's money left over, but based on that answer here, I don't know how much is left over. I just know that there will be money left over because he could have bought more than 5, but they don't sell them that way, so he really couldn't. Based on money, he could. Based on how candy is sold, he couldn't. So there would be leftover money, and we could figure out how much leftover that would be, but we're not going to in this video. Goodbye.